Am I audible? Hello. Hello. Am I audible? Hello. Hello.
But wait for a
Yes, sir.
five
Yes,
minutes.
sir. Yes, sir. You may audible, sir.
Yeah. Okay. Thank you. Good evening, everybody. Yesterday, we have started the new topic, injection molding process. We have already completed compression molding process and transfer molding process. We have seen few slides of the injection molding process. That is just introductory because we have seen the different layouts of the injection molding machine and the history of the injection molding machine, right? How they uh, conclude that the reciprocating screw type injection molding machine will give the best result to other configuration of the or other layout of the injection molding machines. We have seen the different layouts of the injection molding machines. These are the torpedo type, one screw and one torpedo type, one plunger and one torpedo type, and lastly one the reciprocating type of injection molding machine. I also inform you there are machines available that is a hand operated. That is called as hand operated injection molding machine. There are some drawbacks. I told you yesterday, torpedo type machine, the mixing, homogeneous mixing, homogeneous plasticization, color mixing. These are the problems. And you will not get a quality article. Then torpedo and plunger type machine, the second one. I will show you that. So friend, see this, the torpedo type first, second torpedo and plunger. The third one is screw and plunger. And the last one is reciprocating type injection molding machine.
Sir, in presentation mode. Hello,
Yes.
संदीप शिंदे बोल.
Sir, बोला ना.
प्रेझेंटेशन मोड मध्ये करा ना.
Okay. I will do that. 1 minute.
थँक्यू सर.
Yeah. See the friends, torpedo type, first one, the drawbacks of that. Second, torpedo with plunger. The third one, screw and the plunger type. And the last one is reciprocating type injection molding machine, screw type machine. And this last machine is accepted by the industry because it have a lot of benefit over this above three layout of the machine. What are the benefit? A complete quality article you are getting, that is we want. Second thing, very sophisticated machine. Third thing, cycle time is very less as compared to the other. Energy consumption. Energy consumption is the lowest. If you see the other three layout, lowest the energy consumption. The process plasticization is very good, excellent. The mixing of the material or color is also excellent. And hand operation, semi-auto operation, and auto operation can be easily possible by this machine. Also, it is a microprocess based machine. Right. Just 1 minute, friend. Just 1 minute. I'm not. Uh, uh, can I talk with Sandeep sir? Hello. Hello. Am I audible? Friend?
Yes, sir.
Yeah. Okay. Friend, I told you the advantage of the reciprocating type of injection molding machine. The last one. See, now what are the equipments which give the sophisticated and easy movement of the parts? Plus, it is a get microprocess attachment and a completely optimization can be carried out. We have this type of machine and this type of machine is accepted by the all plastic industry. Now, what are the elements present in a injection unit? I told you yesterday, the machine is divided into two parts, injection side and the clamping side. Now, we will discuss first injection unit. Now, what are the components present in the injection unit that we are going to discuss today? Which are the components? Because if you know the machine, then you can understand process easily. What are the component of the machine? I told you machine divided into two part, injection as well as compression, clamping unit. What is the work of injection unit? What is the function of injection unit? It will plasticize the material in the barrel with the help of rotation of the screw and will inject the material by force into the mold. This is the main function of injection unit. The clamping unit, which will help to hold the mold, to close the mold, and to open up the mold with the variation of the different operations. This is the function of a clamping unit. Now, friend, these both units are very important. Now, very important is that if you see the clamping pressure should be higher than the injection pressure. Can anybody tell me why this, why compression, why clamping pressure should be higher than the injection pressure? Okay, definitely we'll get this answer after some few hours. See now here, we will go through details of the component of the injection unit. See here, friend, the nozzle is here, barrel heaters are here, 1, 2, 3, 4, 5, depends upon the length of the barrel. There is a screw is there, which have a thread. That means the plight are present there, plights or thread, both are same. This is the nozzle of the machine. Here, the tip of the screw, the valve of the screw. Here is a check valve of the screw. The screw tip here, see a screw tip is here. Barrel heaters, band heaters are there. This is a screw and the screw drive arrangement. This side, back side, rear side of the injection unit. And very main part is that important part is a feed hopper. It's a very important part of the machine. What is the function of each part here? Let me explain you. First, we will see the screwdriver arrangement. Here, a motor is attached to this screw here, the shaft of the screw. It is attached with the help of some gear systems, which will reduce the speed of the screw. We do not want to impart all the rotation of the motor to the shaft of the screw. Therefore, the screw drive system is there with the help of coupling or gearbox. Now here, to the motor attached to this screw shaft here, here is the shank, there's a hub is there, and this is the system is get attached with the drive systems. The main function of motor is to rotate the screw. Here, in this case, screw rotate anti-clockwise direction. Anti-clockwise. Remember this thing. It rotate anti-clockwise, and while it rotating, it comes backward direction like this. It come backward direction. Now, if you see, when it rotate anti-clockwise in a backside backward direction or rear side of the this drive system, that time the material will fall from hopper to the throat, from throat to the feed section. Here is the feed section is there. The material will fall here, friend. And therefore, the screw drive will, with the rotation to the screw, anti-clockwise, screw rotate backward direction, and the material will flow. This material will flow forward direction like this. See the arrangement of the flight or of the threads. When the screw go backward, that time a granule, plasticized granules, they are softened and get forward direction. Here, there are three sections are there. One is a feed section below the hopper, then compression section, and the last one is a metering section. Metering. It is also called as a melting section. Metering or melting section. यहाँ पे all plastic granule convert into a liquid flow, convert into the liquid, molten mass. Here in compression, the granule are softened. They are converted from solid to liquid, where in the compression section, plus the pressure is applied in this section. And that's why the name is compression section. Now, the last one is the feed section here. The material fall. I told you when the material fall, when the screw coming backward direction by anti-clockwise rotation. See now, friend, below the hopper, therefore, let me again explain you the function of this drive system. What is it doing? It with the rotation to the screw, and second, it will push when the screw coming backward direction. That time it create the short at the front side. Here. The screw tip may be here, and here may be the short prepared by the screw. Now, this plastic material here, gather here at the front side of the barrel, at front side of the screw tip here, that material has to pass into the mold. How it is a pass? Here, screw is now here, the tip is now here. And that type of injection, the screw coming forward direction like this. It is going like this, forward direction, just without any single rotation. It just push the material here, which is present here, from here to into the nozzle, then sprue, runner, and gate, and then cavity. The material, plasticized material, plastic material, melt will pass from this place to into the mold. Through this sprue, runner, and gate system of the mold. Now, yes. 1 minute. 1 minute. Now, friend, see the screwdriver arrangement, screw rotation and pushing of the material. While screw going forward direction, that time there will be not a single rotation. But while the screw coming backward direction, that time it rotate anti-clockwise and coming backward. That time the material fall from hopper throat and it will go through this feed section, compression section, and it is coming to the metering section, and metering section will pass to the material in the front direction, and it will gather here. And this is called as the injection stroke. This is called as injection stroke. Now, friend, due to this heater, what the heater will work here? Heater will hit the barrel. See, the band heaters are get connected to this barrel, and the function of the heater to heat the barrel. See the temperature here. Feed section have a lower temperature. This is a feed section here. Lower temperature, some middle temperature. It is a higher temperature here as compared to the feed section. And this metering section is a higher temperature as compared to the this middle section, compression section. And the front one, nozzle temperature. It is a somewhat less, maybe 5 degree, 4 degree less as compared to the metering section. Therefore, lowest temperature, middle temperature, highest temperature, small 3 4 degree or 5 degree less as compared to the metering section at the nozzle. Now, here is the screw tip. It is a conical type seen over here. Why it is a conical? Because the pressure should be uniform. Material should be stagnant here, should not stagnant. Then screw valve. What the valve doing? What is the function of it? When the screw is backward direction here, that time when the screw taking a shot, it is coming forward direction. That time what is happening? That time this valve get open. How it open? How it open? It will not allow to material to go backward direction. It will it will push the material front direction only. The screw valve, check valve. But when the screw coming backward direction by anti-clockwise, that time this valve is closed here, and the material easily go from this place to here, front direction. Due to check valve is now closed. Therefore, this is a function of check valve. When screw coming backward direction, it get closed. When screw pushing the material forward direction in the process, that time it will open. Now screw. Screw have three zones, which are that I told you: feed zone, compression zone, metering zone, and nozzle zone. This nozzle zone is with only the barrel, because nozzle is the part of the barrel. It is not part of the screw. Remember this thing. Here is only screw tip is there. Screw tip and valve. Screw valve. You know the function of screw valve. You know the function of screw tip. You know the function of heaters. Barrel heater will heat the barrel as per we have said on the panel. Lowest at the feed section, middle at the compression section, highest highest at the metering or melting section, and 5 to 6 degree less at the nozzle section. Now, friend, this is the main part or section unit of the injection molding machine. How the screw go forward and backward? Because the oil is attached here. If you pass oil here, it will push this. If it push this, then it will go here. Screw close. Screw forward direction. Now, if you want to take screw backward direction, again, supply here oil and by hydraulic, it will come in backward direction. Anti-clockwise by taking a help of a motor. So, friend, this is a unique design of injection unit. Now, see here, there are number of machines are there. Operators are there. Supervisors are there. It will take the parameters. There is a microprocessor machines. Panels are there. He take the reading. What reading is he taking? All temperature parameters, screw speed, pressure parameter, material specification. Yes, there are many machine placed online. See here, huge industry. Now, see here details. A injection unit is here. Material in the red color. Screw is there. Nozzle. This is called as a reciprocating screw. Why is a reciprocating screw? Anybody can tell me? Hello, am I audible to you? Hello,
Yes, sir. You may audible, sir.
audible. My question is that why this screw is called as a reciprocating screw? Can anybody tell me?
Because while both phase right, while metal injection or forward backward movement is there, that's what we are telling reciprocating.
Correct. बराबर. बैकवर्ड मूवमेंट कैसा होता है बाय रोटेशन एंड फॉरवर्ड मूवमेंट कैसा होता है जस्ट पुशिंग there is no single rotation of the screw. Very simple. While going forward, screw cannot rotate at a single rotation. But while coming backward, it start to rotate.
I think my understanding both case screw is rotating due to rotation only that friction due to friction that converting into heat energy melting.
No, you are right. By friction, heat energy will involve in that. By sharing action, the material, it will help to melt the material. But when screw coming backward direction, that time only it rotate. Because by rotation, it is coming here up to this place. Are you getting me? See here, this tip is coming here. And therefore, at this place, here is a material, only material for next shot. Next shot के लिए, it will prepare the material in a front direction here. And therefore, now suppose here's a tip is there, here's a material is there. Therefore, it will just push the material from direction. This one, push the material. And hence, while going forward direction, only the pushing, injection done by only the pushing, not a single rotation of the screw.
Okay, you mean to say while injection, there is a no rotation of the screw. It's a
Correct,
direct movement is there.
correct, 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 correct.
And while backward movement, that it have that only then its rotation is there.
Yes, correct. Screw rotation is there. Screw rotate anti-clockwise
Okay, okay.
and it will
I was
prepare the
not aware.
shot.
I was not aware about this. I thought both cases is rotating. Okay,
No, no,
good,
I
good.
want many students also don't know about this. Correct, you are right. This is a miracle here. Only the screw rotate anti-clockwise and coming backward. At that time only the shot will be prepared. That time only the material fall from this place to here, and it will get pushed from this place to here, here to here, and lastly the material will gather here completely this portion, and this screw tip. See the black tip. It is coming here, and now while injection, the screw go like this forward direction, and that time this material will get force by the screw tip, and it will injected through this screw runner get into the cavity. यहाँ पे जाता है material. This is the mode, and this is the clamping unit, complete clamping unit. This is a barrel. These are the heaters on the barrel. This is a cross section view of the injection molding machine.
So where is the tip? Where is the tip?
Where is that?
Tip, nozzle tip.
Nozzle tip is here. This is black one. See here. This is a black one. See
Okay,
here.
okay. Nozzle tip is a part of a barrel or screw? Screw.
No. Screw tip. Screw tip is here. This screw tip and barrel having a nozzle here. यहाँ पे nozzle होता है. Barrel having a
Okay,
nozzle,
okay, okay,
not
okay, okay,
screw.
okay. Okay.
A screw is not attached to the nozzle. Right. Remember this thing.
Yeah,
Screw
yeah.
tip.
Sorry, yeah,
Uh,
yeah, yeah, yeah.
yeah.
It's very clear.
Screw.
Yeah.
Yes. Therefore, see here, the motor will rotate at the time of screw rotate anti-clockwise. But how can screw go forward? There is the arrangement is there. No, two-way cylinder is there. Two-way cylinder. If you pass the oil here, it will push the screw forward direction. And when the oil pass here, it will taking a backward direction. Right. Therefore, by oil, go forward and coming backward. But for the rotation, you have to add the motor here. Therefore, at the backside of the screw, there is a motor as well as oil with cylinder, piston, two-way piston, double acting piston बोलते हैं उसको, double acting piston. I will show you all these things. Don't worry. I have some slides. See here now. One minute.
Hello, sir. Are you there? Are you telling something? Hello?
Yes, yes. Hello.
Yeah, okay, okay, okay.
Yes. Friend, if you see here, the clamping bar, I told you yesterday only, backside, this one, four bars, one, two, three, and four. There are four bars on which this movement of this movable pattern, see now here is a movable pattern, this one, it will move from this place to this place. This is the rear pattern. This is a movable pattern, and this is a stationary pattern. Yeah, stationary pattern. See, this is a three-dimensional view of the injection molding machine. Here is a mold cavity and a female mold core. There is
Sir,
a male
you will
mold.
share this slide now. You will share
Yeah,
the
yeah,
all these
yeah.
slide, right,
Don't,
sir?
yes, yes, yes. Don't worry. Mold core. This is a mold core here. The tie bar here. See, one, two, three, and four. There are four tie bars are there. Okay. Now, ejector bar. This is ejector bar here, which will help to eject the article. The ejection system is here. Here is a molded part. The red is a molded part. Here is a sprue is there. The runner and gate. Gate is here. These screw plates are there. Screw tip is there. Hopper is there. Friend, see now at the this is the throat of the hopper. I will show you this slide. See now here. This is the throat of the hopper. This throat of the hopper here, the cooling system is provided. Cooling systems like a spring is there. Spring type of structure is there. Not spring type of structure, and it gets surrounded by this throat. Therefore, and it have an inlet and outlet. From inlet, you are passing the chilled water, and outlet, the hot water will coming out. Now see here, because this barrel is heated, there are heaters are there on the barrel. Therefore, see now here, see now here, they have not shown here, but here is a cooling channel around this throat. ऐसा वन टाइप ऑफ वन टू थ्री फोर लाइक दैट ऐसा उनको राउंड राउंड होता है वो एंड इट हैव अ इनलेट ऑफ चीड थोड़ा टेम्परेचर में बी लोअर 12 or 15 temperature and there is a outlet. Why it is given here chilled water at the throat of the hopper? Because you are supplying here heat to the barrel. See here, and this heat will by conduction it will go to the hopper through this throat of the hopper, and therefore to insulate, we want this throat should be a chilled one, not hot one. If the heat is supplied to this throat, what will happen? The material will start to melting here only. Once the material melt here, how can the granule fall from a hopper to the throat to the barrel? Not possible. And therefore, to avoid melting of the material, to avoid melting of the material at the throat, we are supplying a circular pipe water around the throat of the hopper here. And due to that, it is get cool. We can restrict the heat here by providing the cooling channel. And therefore, the granule fall from hopper to the barrel in the feed section. Otherwise, material will start to melt here. And therefore, Remember one thing, when you start the machine, before starting, you have to start this cooling of the throat first. Remember this thing. And then you add here, start the heating of the barrels. No problem. Any question here, friend? Any question? Hello? Any question here? Any question about this 1, 2, 3 slide?
सूर्या सूर्या
हाँ, बोलो बोलो बोलो.
So I don't know if they are Kalanidhi.
Hello? Hello?
Sir, you are audible. Don't worry about that.
Yes, yes, yes. If any question, if any difficulty, please ask me. I am here. You should know the process. You should know the function of each part of the machine, and you can able to talk about injection molding machine. Any doubt, please ask me. Now we will go some next part. See, the heaters are here, barrel is here, the molten, this red color is a molten mass. Plastic get melted here. See now here. This screw is called as reciprocating screw because it go forward and coming backward, go forward and coming backward. And that's why it is called as reciprocating screw. While going, no, no rotation. While coming backward, anti-clockwise rotation, maybe 80, 90 per minute rotation. Speed is there, 90, 80, 95, depends upon the machine and material. I told you the throat of the hopper is chilled one because water circulation pipe is going on here. I told you one thing, keep in mind, before starting machine, you have to supply a chilled water around the throat of the hopper. This thing you have to do first, before starting the machine. And then you start the heating. Start the barrel heating. Set the temperature on the panel. Feed zone, compression zone, metering zone, and nozzle zone.
Sir, what about controller? What about controller?
Control panel. Hello.
There will be control panel, right? Yeah, controller. Yeah, control panel. Yeah.
Correct. Now we will see the steps of the injection molding. Now first step is mold closing. See now here, it is the injection unit. This is a fixed pattern here. The cavity is attached to the fixed pattern. Remember this thing. Always remember this thing. Cavity is fixed on the fixed pattern here. and the core is always on the movable pattern. Remember this thing always. Core is always on the movable pattern. This is a movable pattern. Anybody will ask you where you will fix the cavity. Tell them that I will fix the cavity on the fixed pattern, first fixed pattern, and the core on the movable pattern. There are three patterns. One fixed pattern, front is called the front fixed pattern. This is a movable pattern. And the third here, I will show the machine. Yeah, see now here. This is the third pattern. It's a fixed pattern. It don't have a moment. But see, this pattern have a moment. Going forward, coming. Now see, mode is closed condition. Therefore, it is the front side. When mode open, it will be here. And this is a rear side, back side of the pattern, back pattern. This is a front और स्टेशनरी प्लेटन बोलते हैं इसको, फ्रंट प्लेटन और स्टेशनरी प्लेटन. ये भी स्टेशनरी है, ये भी स्टेशनरी है. You cannot change this position of this. And therefore, friend, always remember the cavity is fixed on the fixed pattern by Allen key or by using a nut and bolt with the help of clamps. Clamps are here, and by using the clamp, right, you can fix this Allen key. By using the Allen key, you can fix this female mode on the fixed pattern and male mode or core on the movable pattern. This is the first step. Therefore, we have opened the mode first. Now, mode filling. Mode filling. When you close the mode, after closing mode, you have to fill the article or mode. See now, mode now closing in this case. Now the third one, packing, holding and cooling. After filling the article, एक बार इंजेक्शन हो गया, देखो स्क्रू कमिंग बैक फॉरवर्ड. यहाँ पे देखो स्क्रू ने क्या कर दिया है, मटेरियल को अंदर डाल दिया है. स्क्रू रनर गेट एंड देन कैविटी. The cavity is now filled here. Mold is now filled here. After that, what is happening? Once the mold close, these three operation will take place. कौन सा? Packing, holding, and cooling. These three operation will take place, friend. Packing, holding, and cooling. Now, once this cooling finish, packing, holding, first packing finish, then holding time out, then cooling time out, then what will happen? Mode opening. Now you have to open the mode. Article is formed now. Article is formed. Now you have to open the mode. Then now, screw is now backward direction. It prepare the shot. See now यहाँ पे orange दिखता है. It prepare next shot now. See now here, when the article completely form here, that time see now screw going backward direction. Your gate is freeze here. The material is here now. That is called as the injection stroke. For the next cycle, for the next shot. Now, when the article now cool after packing, holding, and cooling, the article become hardened. Then the mode will open, opening of the mode. When the mode opening, at the time of opening, the ejector pin will push the article. See, immediately it will, same thing will be now happening here. Molding mode open and ejector pin activation. Same time. Therefore, यहाँ से opening हो रहा है और यहाँ से ejection pin will push the article front direction from the core side. See now, this is ejector pin. यहाँ पे इधर से and इधर से 3 ejector pins, 1, 2, and 3. It will push the article front direction when the mode is open. Now injection cycle time. Typical cycle time of injection molding. Mode close 1 to 2 seconds. See the timing. Injection 2 to 5 seconds. Now, why the time is very less or mode close? If the article is very high volume, then the mode will take the same timing. It is not on the related with the volume and less volume and high volume. Then when the mode close, that time initially it will take a small speed, then very high speed afterwards, and then when the mode closing, very low speed. The mode opening is slow, high, and slow. See the speed, slow, high, and slow. And for that speed, it takes only 1 to 2 seconds. Injection, 2 to 5 seconds. The material on the front side, which will you have to pass into the mold, that takes the 2 to 5 seconds. Then pack and hold. I told you packing, holding, and cooling. Pack and hold take the 8 to 10 seconds because the article should be formed there. There should be pressure on cavity and the core. And therefore, it take 8 to 10 seconds. Part cooling. Cooling take a maximum time. See, same in case of a compression and transfer molding process. 10 to 20 seconds, highest time. Anybody will ask you, which operation take a more time in an injection molding cycle? We should be able to tell them that the cooling of the article, cooling section, it will take them more time, more than half time, half cycle of the time. And that's why, as compared to the compression and transfer, it take a lower time cycle. Now screw return 2 to 5 seconds. See, mode closing 1 to 2 seconds, but screw return 2 to 5 seconds. Mode open only 1 second. Why the closing is taking a 1 to 2 seconds and mode open only 1 second? Because now there is a no any fear about the mode damage. Opening just you are opening the mode. Finish. Therefore, again slow, fast, slow. Same speed. Slow, fast, slow. Now ejection only 1 second. And hence, if you see the cycle time, it may be 20 second, 25 second, 35 second, 30 second, like that only. See the efficiency of the machine, friend. If you calculate this time, twenty-five, 30, 35, 40, 45, depends upon the article size. Therefore, size, thickness, cooling temperature will all the parameter affect the cycle time. But anybody will ask you about the curing time or a hardening time. It is a maximum 10 to 20 seconds. It's a very miracle, friend. Cycle time of the injection unit, it depends upon, there are many factors are there, cycle time. What type of material you are using, preheating is there or not, then screw ka dimension, then article ka, weight, article ka volume. There are many factors, the cooling temperature, then heating temperature. There are a number of factors. You are cooling the mode here. You are not cooling the barrel. Remember this thing. You are heating the barrel and cooling the mode. Generally, the temperature is 18 degrees to 20 degrees Celsius, which we are supplying to the mold. Any question here, friend? Any question here? Am I audible to you?
Yes, sir, you are audible, sir. No
Yeah,
question, sir.
okay. Okay, okay. See,
Maybe, sir, maybe one question. Are you going to cover blow molding process also?
yeah. We will cover blow molding. Don't worry. We will all type of blow molding. Don't
All
worry. There
okay,
are
okay, great, great, great,
there are
great.
four type.
And sir, uh,
We will go in detail.
one more
Don't worry.
request.
Yes, yes,
Great.
yes. Don't worry. Don't worry.
What is my request? Maybe end of the session.
Uh-huh.
Maybe after a week or maybe as per you,
Uh-huh.
the comparison of the all the parameters like between injection molding, transfer molding, compression molding, blow molding,
Yeah, yeah.
all maybe tabular format. If you can get comparison that of all parameter, it will give a glimpse of
Yeah.
understanding better.
Correct. Even I am going to show you. If you see the slide, my slides, it also have that temperature parameters. If you
I agree.
just
I
yes,
actually theory
that
form is
time
okay, but
if
human
if
mannequin is
if
more understanding. If there
if
is a
you are
tabular format comparison is there, that will more insights
yeah,
kind of.
correct. I agree with you, right? Comparison, but with the process are different process are there, right? Compression is a complete different. The transfer is also complete different.
I
Injection is
agree.
again,
Sir, I
yeah.
agree. I
Yes.
agree. Both all are different, but let's
Uh,
suppose any parameter, temperature, or cooling time, all
huh.
all are
No.
for all.
My
If
no.
that parameter is not applicable for that process, we can mention not
Correct.
applicable kind of maybe. Yeah.
No. One thing is there, friend. What is happening? that depend of the size of the machine, depend of the article of the machine, depends upon the material, which material you want parameters. You want ABS, you want nylon, you want nylon 6,6, you want nylon 4 and 6, you want to polyethylene, polypropylene, ABS, polystyrene, acrylic, polycarbonate. There are number of plastics, friend. And on which type you want, that is a very important, right? Suppose I will give you one parameter, you will apply that the same parameter. It is not good. Therefore, you have to go through the material, which there are, see, variety of the material, you know very well. Engineering plastics, commodity plastics, specialty plastic, high-tech plastics, right? There are number of plastics are there, not a single type. And therefore, this parameter goes on changing, right? As per the melting point, as per the molecular weight of the polymer.
I
Even
agree,
I
sir.
told,
I agree.
I
There
suppose,
variation are
suppose,
there.
suppose I am giving you the polyethylene. Suppose polyethylene. No, there are number of grades of polyethylene, right? LDP, LLDP, SDP, VLDP, MHDP, ultra high molecular weight high density. There are 5 to 6 grades of only polyethylene, and all the parameter are changing there. There is not a common parameter for this, you see, right? And that's why if the one family also not showing, but there are a different type of polymers. There are different type of, see, there are monomer. They are different, right? As the engineering polymers. See the now thermoset material. We are cooling. We are heating the mold in case of a thermoset. But here in thermoplastic, we are cooling the mold. See this is a big difference, right? Therefore, such a type of parameters. When I
I
am
agree,
giving a,
sir.
yeah,
Sir, I agree. I can understand
I
what
I
you're
am
telling.
I am yeah I am giving,
Let's suppose the cooling point of view, cooling time.
yeah, cooling time. Yes,
That
yes.
in general we can
Don't
mention, or with asterisk, might it be
yeah
possible.
don't worry. I am giving you all parameter. Don't I have a chart? Don't worry. I will add that chart now. Now you
Great, sir.
told me now. Yes, definitely I will add that chart. All parameter chart. Okay, don't worry. Front temperature, initial temperature, cooling temperature. I will put that. Even barrel temperature also I am going to put. Don't worry. Okay. Yes, I will bring that. Don't worry. Now see here. Uh, see the tonnage, right? Now what type of tonnage you want? 1 tonnage, 2 tonnage, 3 tonnage, as per the, that what type of clamping force you want, right? That clamping force is always measured in case of a tonnage, right? That we have to measure there, right? And that's why I told you clamping pressure should be higher than the injection pressure. What will happen? Suppose now see here, in this case, the see the here, दिस प्रेशर, ये जो दबा रहा है, ये क्लैंपिंग हो रहा है इधर, ये फीमेल मोड एंड मेल मोड, ये क्लोज कर दिया, इसका प्रेशर लोअर देन दिस प्रेशर, व्हाट विल हैपन? ये लोअर है, ये लोअर है और ये हायर प्रेशर है, व्हाट विल हैपन? द मोड इज ओपन हियर, material will come out from this place, and therefore this pressure should be higher. Clamping pressure should be higher than this pressure, injection pressure. ये injection pressure and here clamping pressure. Clamping pressure should be higher than the injection pressure. I want to tell you this thing, right? Otherwise, if this pressure is higher and this pressure is lower, that time the mold may be open and the material will come out from the mold. This type of things you should have a keep in mind. Now, friend, we have already seen this slide equipment ka. See, these are the different machines are there. Injection units are here. See now here, a big unit is there. See also, there is also a small type of units is there. Only injection unit. See, this is here platform. The screw is there, and see now here. See drive system they have shown here. The drive system. By this only way, the screw rotate anti-clockwise and coming backward direction. Now we will go through details about the screw now. Screw of the injection molding machine. See, this is a geometry of the screw of the injection molding machine. There are 3 zones, I told you. Feed zone, इसके ऊपर ये हॉपर रहता है ऊपर इधर, यहाँ पे हॉपर रहता है, फीड जोन, compression zone and metering zone. What is the function of feed zone? The function of feed zone is to take the material from the hopper. यहाँ से hopper है, यहाँ से material लेना, इसका काम है. See the flight depth. Flight depth is higher in this case here. Very high flight depth. Here flight depth goes on decreasing. कमती कमती हो रही है. See now here up to here, and here the flight depth is less as compared to this. See now this is a very high flight depth. See here, low flight depth. See the gap here, lower. See the gap here, higher. Therefore, friend, flight depth is higher in a feed zone. Then, second, the flight depth is goes on decreasing from feed zone to the metering zone. See now here, here is higher, lower, 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 and lowest. The flight depth goes on decreasing. देखो ऐसा. Now, in case of a metering zone बोलते इसको, metering zone or metering zone. Here, the flight depth is constant. इधर जितना है उधर उतना है, इधर इतना है उधर उतना है, जो एक कांस्टेंट रखा है. सपोज 5 mm 5 mm 5 mm बस. इधर ऐसा नहीं है, इधर तो डिक्रीज हो रहा है. सपोज ये 8 mm है, इधर 7 mm 6 mm 3 mm 2 mm like that goes on decreasing. In feed zone, see, constant flight depth. सपोज इधर है 8 mm 8 mm 8 mm 8 mm 8 up to here 8 mm.
So you mentioned a previous sentence that in compression or metering zone it reducing that pitch or what? I
No. Again, I am telling you. Listen now carefully. See, there are two diameter. देखो, ये जो ऊपर का डायमीटर देखो, यहाँ से यहाँ होता है स्टार्ट. इसको बोलते हैं डायमीटर ऑफ स्क्रू. क्या बोलते हैं? डायमीटर ऑफ स्क्रू. दूसरा जो डायमीटर है वो ये वाला डायमीटर, ये इतना ही बस. इसको बोलते हैं रूट डायमीटर. क्या बोलते हैं? रूट डायमीटर. इसको बोलते हैं फ्लाइट 1 2 3 4 5 6 7 8 लाइक दैट. फ्लाइट. दिस ऑल आर फ्लाइट. और थ्रेड, तो थ्रेड ही बोलते हैं, थ्रेड 1 थ्रेड 2 लाइक दैट. द स्क्रू डिवाइडेड इनटू 3 पार्ट: फीड जोन, compression zone and metering zone. फीड जोन का काम क्या होता है? फीड जोन टेक मटेरियल फ्रॉम द हॉपर. जब मटेरियल हॉपर से लेता है, इसीलिए तो ये इधर थोड़ा गैप है, इधर और इधर गैप. तो बड़ा बड़ा गैप है, बड़ा गैप इधर इधर. मटेरियल गिरने के लिए मटेरियल शुड फॉल हियर. मैक्सिमम मटेरियल शुड फॉल. एंड दैट्स व्हाई द चैनल डेप्थ, इसको बोलते हैं चैनल डेप्थ. ये चैनल डेप्थ इज हायर हियर, channel depth is lower here. देखो कमती कमती हो रहा है. and channel depth is a very lower here, lowest channel depth. देखो इतना गैप कितना है, देखो इधर ये गैप कितना है, बहुत बड़ा गैप है. तो इसके अंदर ये ज्यादा गैप क्यों दिया है? मटेरियल ज्यादा गिरने के लिए, राइट. मैक्सिमम मटेरियल शुड बी फॉल फ्रॉम द हॉपर टू द बैरल. यहाँ पे मटेरियल गिरना है. तो इसको बोलते हैं फीड जोन. फीड जोन कितना होता है परसेंटेज? 50% है फीड जोन. ये जो स्क्रू लेंथ इतना बोलेगा तो ये 50% का है. कौन सा? फीड जोन. बहुत लंबा है. फिर 25% कॉम्प्रेशन एंड 25% में ड्रिंक जोन. 25, 25 and 50. This is the called as a general purpose screw. जो स्क्रू 4-5 मटेरियल के लिए काम पे आएगा, ऐसा स्क्रू है ये वाला जनरल पर्पस स्क्रू। इट इज फॉर 3 to 4 मटेरियल पे काम पे आएगा ये स्क्रू। नाउ इफ यू सी हियर द चैनल डेप्थ, इसको बोलते हैं चैनल डेप्थ। तो कांस्टेंट हियर, देखो इधर सेम, इधर सेम 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 यहाँ तक। बट यहाँ से क्या हो रही है, कमती हो रही है चैनल डेप्थ, कमती 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 हो रहा है। देखो इसका साइज देखो बड़ा है, देखो यहाँ साइज छोटा है, ये बड़ा और छोटा। तो ये चैनल डेप्थ गोज ऑन डिक्रीजिंग। देखो रूट डायमीटर, इसको रूट डायमीटर बोलते हैं। रूट डायमीटर सेम है, देखो कांस्टेंट कांस्टेंट सेम है इधर। सपोज इधर ये 8 mm है, 8 8 8 8 8 8 mm यहाँ तक, 8 mm। बट नाउ सी नाउ हियर, इधर क्या हो रहा है, इधर छोटा है, इधर बड़ा हो रहा है, इधर बड़ा हो रहा है, इधर बड़ा हो रहा है, इधर ऑल्सो गोइंग टू इंक्रीज, राइट। द रूट डायमीटर गोज ऑन इंक्रीजिंग in case of a compression zone. But in case of a metering zone, the root diameter again constant, देखो same है। Suppose 12 mm, 12 mm, 12 mm. Therefore, root diameter same here, flight depth same here. Here, root diameter goes on decreasing from feed zone to the metering zone. देखो कमते कमते हो रहा है। See now here, feed zone, it is a constant. Root diameter is a constant, and flight depth is also constant here. It is called as a screw length. यहाँ पे बोलता है स्क्रू लेंथ। सपोज स्क्रू लेंथ आपने यहाँ से लिया, इधर से लिया, तो इसको बोलते क्या है, ओवरऑल ओवरऑल स्क्रू लेंथ और टोटल स्क्रू लेंथ। ये इधर शैंक होता है, हब होता है, वो इधर पकड़ा नहीं है, दिखाई नहीं दिया। यहाँ पे होता है स्क्रू टिप, स्क्रू टिप इधर होता है, इधर ऐसा कोनिकल टाइप का, तो ऐसा ऐसा, इसको बोलते हैं स्क्रू टिप। नाउ फ्रेंड, इफ यू सी नाउ हियर, if you know the screw, then you will able to tell something. See now, this portion is called a land. This is called as a land. This is called as a pitch. Distance between two thread. Distance between two thread is called as what? Pitch. This is the outer diameter, OD, or diameter of screw. This is a root diameter, chota wala, or root diameter. Now, see now, we have to see now, here, there are some valve. See now here, ring valve is there. देखो ये somewhat, see the color here, orange color or pink color, both pink color. This is a valve is here. When the screw goes backward direction and when the screw goes forward direction, I told you just now. When this valve, pink is valve. When this screw goes backward direction, that time this valve will go here. It will push here because of the mate. Therefore, valve will open and the material will pass like this. ऐसा material यहाँ से आगे जाएगा. When the screw goes backward direction, that time this valve is open. See now here open. Material will go front direction. But when the valve is closed, see now here, valve कैसा है, close है. There is no gap here. Gap है ही नहीं है. ये जो gap है इधर का gap किधर है? नहीं है वो gap.
Sir, one doubt.
हाँ
You are telling this second image during plasticizing, right?
हाँ हाँ
Valve is open.
नो व्हेन यू टेक द शॉट, देखो अभी यहाँ पे दिस इंडिकेट्स ये इंजेक्शन हो रहा है, यहाँ पे मटेरियल आ गया, ये पुश कर रहा है स्क्रू को, ये स्क्रू है, स्क्रू पुशिंग नाउ, जब पुश होता है तो ये वॉल है ना ऑटोमेटिकली इधर आ जाती है,
खुल जाता है,
बिकॉज
मेटल
हाँ,
जाएगा फिर।
तो बिकॉज इधर 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 सब मोल्टन मास है, सब मेल्ट है। देखो ये बांध दिखाया है, ये वाला, ये एरो क्या इंडिकेट करता है, मटेरियल, मटेरियल इसको क्या करता है, ऐसा पुश करता है इसको, फिर यहाँ से मटेरियल यहाँ जाएगा ही नहीं, बिकॉज इट इज नाउ सी क्लोज हियर इन दिस केस, सी नाउ हियर, हियर आपका क्लॉक एंटी क्लॉकवाइज ये हो रहा है, उसको रोटेट हो रहा है, मटेरियल मेट जो है, मेट यहाँ से पास से ऐसा 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 इधर से ऐसा इधर खचा है, यहाँ से मटेरियल आगे जा रहा है, दैट टाइम दिस wall is open, see, by force by force the material will go like this. This wall, the ring is open here, the ring is open here in this case, and therefore the material will pass like this, but in this case यहाँ पे इंजेक्शन हो रहा है, the wall is now here, here close हो रहा है, हो गया, तो मटेरियल यहाँ पे मटेरियल है, ये इधर से नहीं जा रहा है।
Sir, but during injection process,
हाँ हाँ
material should go to the mold.
करेक्ट
Wall,
करेक्ट,
wall,
तो
wall should be
हाँ
closed, wall should
तो
be open now.
हाँ, no 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 no, that's why material here, material is here, material already, हाँ आपका बराबर क्वेश्चन है ना, करेक्ट, wall should be open while type of injection, बराबर ना बोल रहे हैं आप, बराबर ना,
Yeah. So
हाँ ऐसा
here
है,
you're telling
हाँ
wall is
करेक्ट
closed. Then
करेक्ट, सुनो सुनो, yes yes you are right now, but you are not imagining that here the material is here, the material यहाँ पे आता है, पहला पहला ही शॉट करता है, जो जो मटेरियल का, देखो अभी मेरा स्क्रू पीछे पीछे जा रहा है, मटेरियल यहाँ गैदर हो रहा है आगे, बराबर है, तो ये देखो यहाँ पे जब मटेरियल आगे आगे जाता है तो यहाँ पे मटेरियल यहाँ आ रहा है, देखो मटेरियल यहाँ जमा हो रहा है, अभी यहाँ से मटेरियल मोल्ड के अंदर नहीं जा रहा है, रिमेंबर दिस थिंग, इट्स अ वेरी गुड क्वेश्चन, very good question. Now see here, the material coming here and storing here, front side of the screw, tip of the screw. मोल्ड के अंदर नहीं जा रहा है ये, it is not going in mold, खाली इधर इधर जमा हो रहा है. I will show the diagram.
okay.
Yeah, yes, that is the thing. I will show you that. हाँ, मटेरियल यहाँ पे जमा हो रहा है, इधर इधर जमा हो रहा है, मोल्ड के अंदर नहीं जा रहा है. When the screw coming backward, that time material यहाँ पे इधर 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 होता है वो मटेरियल. I have some diagram, I will show you afterwards. Right. देखो यहाँ पे मटेरियल जमा हो रहा है, इधर इधर, ये मोल्ड के अंदर नहीं जा रहा है, बराबर है, तो
Material जमा हो रहा है
हाँ
injection at a time of
हाँ
injection, right?
हाँ,
Doing
यस,
injection.
जब स्क्रू स्क्रू बैकवर्ड जाता है, बैकवर्ड जाने के बाद इधर इसके सामने मटेरियल स्टोर होता है, और जब ये स्क्रू पुश करेगा, ऐसा पुश करेगा, तो ये इधर आएगा, ये इधर आएगा, इधर का मटेरियल सब अंदर जाएगा. अभी देखो अभी इधर का मटेरियल है ना अंदर जा रहा है, देखो यहाँ पे इंजेक्शन हो रहा है, यहाँ पे इंजेक्शन हो रहा है, दिस इंडिकेट इंजेक्शन, बिकॉज सी द फोर्स इज हियर, देखो एरो देखो, यहाँ पे क्या हो रहा है, यहाँ पे मटेरियल मोड़ के अंदर जा रहा है, बट इधर क्या हो रहा है, इधर इट विल प्रिपेयरिंग द शॉट, यहाँ पे शॉट प्रिपेयर हो रहा है फॉर द नेक्स्ट साइकिल, फॉर द नेक्स्ट साइकिल, ऐसा होता है, जब स्क्रू पीछे आता है ना, तो ये शॉट प्रिपेयर करता है फॉर द नेक्स्ट साइकिल, नेक्स्ट आर्टिकल के लिए, रिमेंबर दिस थिंग. तो
तो कैसे
आपका,
कैसे पीछे आता कैसे करता है सर, दोबारा बताइए एक बार.
हाँ, जब ये पीछे पीछे आएगा ना, देखो अभी अभी यहाँ पे पीछे पीछे आ रहा है स्क्रू, तो ये मटेरियल यहाँ से ऐसे ऐसे जाके यहाँ पे स्टोर होगा, बराबर है, ये जब स्क्रू ऐसा पीछे पीछे जाएगा, ये वाला स्क्रू, तो यहाँ से ये ओपन हो जाएगा, तो मटेरियल यहाँ से जा
पीछे
रहा है.
पीछे मतलब विच डायरेक्शन, मतलब बैक एरो हेड, बैकवर्ड डायरेक्शन.
देखो ये एरो है ना,
फोर्स.
देखो ये एरो
ओके
इंडिकेट
ओके.
करता है, देखो यहाँ पे जा रहा है मटेरियल, मोल्टन मास, बराबर है.
Right. It
हाँ
will be, it will act as a store of charge for next, right? It
करेक्ट
will not directly, it will not directly go to the injection
करेक्ट
molding.
करेक्ट, एकदम करेक्ट,
Okay.
एकदम देखो सेम था
Now
ना
in
ना।
the now in
हाँ
now in the during injection,
करेक्ट,
this valve is closed. When it will
during
push
injection, no, during injection the valve close and
valve closed, but
हाँ
that this screw will go forward, and from backward that arrow red it will go to directly to injection
करेक्ट,
like that.
करेक्ट, now you have got now, correct, correct, correct answer now,
Okay.
एकदम करेक्ट।
Okay.
therefore it is storing the material, उसको बोलते हैं इंजेक्शन स्ट्रोक। वो इंजेक्शन स्ट्रोक ना वो वो स्टोर करता है आगे। So
Then there will be a then
and
there will be
and
injection
and screw,
stroke.
एंड स्क्रू विल बी बैक साइड, स्क्रू पीछे जाता है और आगे क्या करता है, मटेरियल का शॉट तैयार करता है फॉर नेक्स्ट इंजेक्शन के लिए, नेक्स्ट शॉट के लिए।
तो जो मटेरियल तैयार करता है नेक्स्ट शॉट के लिए उसमें स्क्रू आगे जाएगा, राइट?
करेक्ट, करेक्ट।
ओके ओके ओके।
एंड उसके बाद वो नेक्स्ट शॉट पे क्या करता है, खाली पुश करता है बस। पुश हो गया, इंजेक्शन हो गया, मोड के अंदर मटेरियल गया, जैसा ही मटेरियल के अंदर मोड के अंदर जाता
तो
है, जैसा ही
then
मोड के
then
हाँ
what I understood, the short size which is required for the article,
करेक्ट, करेक्ट।
that area we have to decide, right? How much that short area.
इंजेक्शन, हाँ इंजेक्शन, no, उसके बारे में बोलेगा ना, मैं मेरे पास है, आई विल टेल यू
ओके ओके ओके।
कितना कितना शॉट भर सकते हैं हम लोग, कैसा उसको शॉट करने है, कैसा करने का, वो सब अपने अपने हाथ में होता है सब, बराबर है। तो इसको बोलते हैं इंजेक्शन स्ट्रोक बोलते हैं उसको। कितना कितना लेना है, 1 2 3, मैक्सिमम 4.5 हम लोग रखते हैं, मैक्सिमम 4.5 डी, 4.5 इंटू डी, डी मीन्स डायमीटर ऑफ द स्क्रू, बस इतना ही रखते हैं हम लोग। अभी अभी मैं आता हूँ उसके आगे, आगे वाला स्लाइड है मेरे पास 2 3, तो उसके ऊपर हम देखेंगे। इतना इतना आपको समझ में आया क्या? हेलो, हैव यू गॉट दिस? क्योंकि दिस इज अ वेरी इंपॉर्टेंट पार्ट, wall open, wall close, and dimension of the screw, geometry of the screw।
सर अगर थोड़ा एनिमेशन होता थोड़ा और अच्छा क्लियर हो जाता है, वैसे अभी ये इमेज है
नहीं, हाँ
ठीक है सर।
एनिमेशन है अपने पास है, डोंट वरी, आई विल शो यू एनिमेशन आल्सो, डोंट वरी।
थोड़ा थोड़ा डाउट
यस,
है, जो आपने बताया
हाँ
क्लियर है लेकिन
यस,
थोड़ा डाउट है।
करेक्ट करेक्ट, आई विल टेल यू। हाँ नको सी आ गए स्लाइड। तो इसको बताए इंजेक्शन स्ट्रोक, देखो 1 डी, 2 डी, 3 डी एंड 4 डी। मैक्सिमम हम लोग इतना ही स्ट्रोक रखते हैं बस, ये मैक्सिमम हो गया स्ट्रोक, इंजेक्शन स्ट्रोक बोलते हैं इसको। देखो स्क्रू देखो अभी कहाँ पे है, देखो ये बैकवर्ड डायरेक्शन, अभी यहाँ पे शॉर्ट शॉर्ट हो गया, ये स्क्रू एंटी क्लॉकवाइज रोटेशन करके पीछे आया। देखो यहाँ पे सब मटेरियल आ गया, देखो अभी आप लोगों को कितना है आपका साइज, सपोज 1 डे में इतना ही आता है, तो इतने आर्टिकल भरो, तो स्क्रू खाली इधर आएगा, जब पीछे आएगा तो इतना ही आएगा। आर्टिकल थोड़ा बड़ा है, इतना रखो, आर्टिकल उससे बड़ा है, इतना रखो, आर्टिकल सबसे बड़ा है तो इतना रखो, इसके आगे हम जा नहीं सकते। नाउ व्हाट इज अ 1 डी 2 डी 3 डी 4 डी? इसका मीनिंग कैसा होता है, डी इज अ डायमीटर, सपोज डी इज अ 90 mm, 90 × 1 तो 90, बस इतना यहाँ तक 90 mm जाएगा। ये 90 × 2 180 मटेरियल जाएगा, 120 मटेरियल जाएगा। 90 × 3,
एक तो यूनिट, व्हाट इज द यूनिट फॉर दैट? 20
करेक्ट,
यूनिट।
करेक्ट, करेक्ट। तो हम लोग कितना लेते हैं पीछे, ओनली, बस इसके आगे नहीं होता है। और इसको बोलते हैं
व्हाट
इंजेक्शन स्ट्रोक। इंजेक्शन, लिसन
व्हाट
मी, इसको बोलते हैं इंजेक्शन स्ट्रोक। क्या बोलते हैं? इंजेक्शन, अपने को इंजेक्शन स्ट्रोक एडजस्ट करना पड़ता है। आर्टिकल का साइज, बड़ा आर्टिकल रहेगा तो आपको थोड़ा बड़ा देना पड़ेगा, बट इसके आगे 5 डी नॉट पॉसिबल, 6 डी नॉट पॉसिबल, डिजाइन इतना ही होता है जिससे मैक्सिमम
मींस
मेल्टिंग।
4D, 4D इज द मैक्सिमम।
करेक्ट, करेक्ट, बस बस इसके आगे नहीं।
बट ओके ओके, तो
पर
बेसिकली
आपको,
वी हैव टू डू,
पर सपोज आपको आर्टिकल,
basically what
सपोज,
I,
हाँ
sorry to
बोलो।
interrupt you, what I understood, we have to adjust our that screw to particular position, hit and trial, based on the material required for the article, right?
करेक्ट, यस, बराबर है आपका, यू आर 100% राइट। तो
Okay.
हमारा पास इधर इधर ये होता है, जैसे वन स्केल होता है, स्केल, उस स्केल के ऊपर हम लोग बराबर उसको एडजस्ट करते हैं, ये कितना आगे जाना चाहिए, कितना पीछे आना चाहिए, ये सब हमारे हाथ में होता है। हियर इज अ स्केल होता है, उस स्केल के ऊपर हमने उसको एडजस्ट कर दिया, तो इट विल, स्केल मीन्स देयर आर लिमिट स्विचेस, लिमिट स्विच होता है यहाँ पे, हम लोग इसको एडजस्ट करते हैं बराबर। जैसा आज ये क्या करते हैं, हम ट्रायल एरर से करते हैं। कितना आर्टिकल भरा, अरे 30% बाकी है, तो हम लोग और थोड़ा बढ़ाएंगे, और थोड़ा और थोड़ा स्क्रू पीछे
Then,
लेंगे।
then one doubt: why
हाँ
we
हाँ,
have nomenclature 1D, 2D, 3D, 4D? We can simply do na 1 meter, 2 meter, 3 meter length kind of,
अरे 1 मीटर इतना
because this is
इतना
because
हाँ,
no, no, not meter means like a centimeter or whatever,
नहीं
particular
नहीं डी,
length unit.
नहीं नहीं, डी
But
डी
here,
इज
what? Yeah,
हाँ, डी इज डायमीटर, डी इज डायमीटर, and diameter
is it
means
is it increasing like diameter wise like that?
हाँ करेक्ट, देखो ये नंबर है ना, 1 into dia, वन
Okay, so
टू
means
इंटू
at
डाया
this area the diameter will be 1D, and at the 2D
करेक्ट
diameter will be 2D, right?
करेक्ट करेक्ट करेक्ट, यू आर राइट।
Then is it the compression zone?
हाँ
No, it's a different thing. Okay, okay, got it,
या
got it.
हाँ, इसको बोलते हैं इंजेक्शन स्ट्रोक। आर्टिकल बहुत बड़ा रहेगा तो 4D मैक्सिमम, उसके आगे नहीं। फिर इसके आगे वो बोलेगा अरे हमारा आर्टिकल तो बहुत बड़ा है, तो बोलने का बड़ा मशीन ले लो फिर, बराबर ना, यू हैव टू बाय द बिग बिग मशीन देन फॉर दैट। देखो अभी यहाँ पे जैसे फीड जोन, देखो देखो बराबर है यहाँ पे, सपोज 90 mm रहेगा, यहाँ पे 90 mm है क्या, डायमीटर। देखो यहाँ पे, देखो यहाँ पे कैसा है, ज्यादा हो रहा है डायमीटर, ये इसको बोलते हैं रूट डायमीटर। देखो यहाँ पे देखो कांस्टेंट है, यहाँ पे इंक्रीज हो रहा है, और यहाँ पे देखो कांस्टेंट है। therefore you have to remember that in metric zone diameter is constant, in compression zone diameter goes on increasing, and in feed zone diameter is constant. See now here, यहाँ पे देखो अभी ये स्क्रू एकदम फ्रंट आ गया, यहाँ पे आ गया स्क्रू। ओके, तो कितना देखो कहाँ से कहाँ आ गया, देखो ये इधर आ गया, ये यहाँ तक आ गया, देखो यहाँ तक लास्ट तक, देखो ये टिप यहाँ तक आ गया, राइट। therefore what this indicate that now it is a complete shot now। यहाँ पे अभी ये शॉट ले लिया है, इंजेक्शन हो गया यहाँ पे कैसा है, शॉट बनाया, शॉट क्या किया, बनाया।
Sir, one doubt.
हाँ देखो देखो, तू बोल रहा था ना कि सर वो तो फिर वाल्व कैसा ओपन है, देखो अभी यहाँ पे वाल्व कैसा है, ओपन हो गया है इधर, ओपन हुआ इसलिए तो मटेरियल आगे आगे आया, बराबर ना। अभी देखो यहाँ पे वाल्व कैसा है, क्लोज हो गया, अभी यहाँ से मटेरियल इधर नहीं आएगा, बैक साइड नहीं आएगा, बराबर है, बैक इसके बैक फ्लो नहीं होगा, और यहाँ पे मटेरियल नहीं जाएगा। अभी देखो यहाँ पे भी यहाँ तक आया है स्क्रू, अब इसके आगे यहाँ पे वॉल अभी ओपन हो गया है, अभी यहाँ से मटेरियल इधर से मटेरियल इधर नहीं आएगा, बैक फ्लो नहीं होगा, क्योंकि वॉल इज नाउ क्लोज हियर कंप्लीटली। हाँ बोलो।
Sir, my doubt is that at 4D point, 1, 2, 3D, 4D.
हाँ हाँ
4D means the diameter will be more, right, compared to 1D.
करेक्ट करेक्ट।
Now, when the no this screw, this is a screw tip or what we can do? Okay, position of screw
हाँ हाँ
at 4D will be it's a there will be particular gap. When this position will move to 1D, it will be a interference fit or what? How means?
नो नो, 4D
Or
means इधर diameter is not increasing, diameter not increasing, diameter is constant, this diameter is constant here, but this area goes on, ये जो डिस्टेंस है ना, ये डिस्टेंस 1D 2D 3D 4D, ऐसा इसका
but
मतलब है।
last time when we discussed at 4D position,
हाँ
the
हाँ
diameter of the outer blue one is like 4 times dia. That what we understood.
हाँ,
Is it like that?
नो 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 प्रो, नॉट नो 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 नो, डायमीटर इज नेवर इंक्रीजिंग, डायमीटर जितना है उतना ही है,
Okay,
खाली खाली
okay.
इतना।
Then maybe
हाँ
miscommunication maybe. Okay.
हाँ, यस यस, ये जो इसका डिस्टेंस है ना, इसको बोलते हैं 1 डायमीटर, ये इतना डिस्टेंस और इसका डाया सेम है, बराबर है, ये डायमीटर एंड इतना डिस्टेंस सेम है, ये वाला 1D मीन्स व्हाट, एक डायमीटर, 2D मीन्स व्हाट, ये 2 टाइम्स, यानी इतना इतना पीछे आएगा, screw. इसका मतलब ऐसा है.
Got it. Maybe picture is not like it looking like uniform gap, but practically it will be more gap.
Yes, yes,
One
yes.
time, two time, three
No,
time, four
it
time.
is, but it is, we can adjust the screw position by here, by adjusting here. We have a limit switch here, plus we can adjusting the position. जितना by trial and error methods, we can going to fill the article here. Article कितना भरना है, 10 तक का, no, 100% नहीं भरा, 90% भरा, तो just we take again थोड़ा backward ले लेंगे, थोड़ा backward ले लेंगे, बस. जनरली ये 1 और 2 डे में आर्टिकल भर जाता है, 1 और 2 डी में आर्टिकल भर जाता है, ऐसा ही डिजाइन करते हैं मशीन. बट सपोज आपका आर्टिकल थोड़ा सा 90% भरा, कुछ है, कुछ पार्ट बाकी है भरने का, तो उसको थोड़ा पीछे, स्क्रू को थोड़ा पीछे यहाँ तक लेके आएंगे. और फिर क्या हो गया, सपोज ज्यादा हो गया, ज्यादा पीछे आया तो फ्लैश आएगा, अपने को मटेरियल वेस्ट हो जाएगा. बराबर है. तो आपने को क्या करना है, यहाँ पे एडजस्ट करना है, वेरी सिंपल. और वो एडजस्ट हमारे पास होता है भाई, लिमिट स्विच हम लोग एडजस्ट करते हो. any question again here, friend? Any question? This is a very important slide.
Sir, this after metering is started, you explain the top. Are you this slide finished or you are going to continue?
No, I am going to continue.
Okay,
We
please
have
continue, sir. Yes, sir.
we have a 24 minutes और भी है अपने पास. मैं आगे जा रहा हूँ अभी. Okay. Now see now here, any machine.
No, backslide, sir. Backslide is finished or okay.
Yes.
In that
Go on.
in that metering restarted.
Metering.
What is that,
This
sir?
is this is a metering section. This is a metering section. This is a compression section. This is a feed section. फीड का काम क्या, मैक्सिमम मटेरियल लेना. देखो यहाँ पे गैप है, देखो बड़ा, बराबर ना. यहाँ पे मैक्सिमम मटेरियल आएगा. देखो यहाँ से ग्रेन्यूल गिरता है ना, तो यहाँ से देखो मैक्सिमम मटेरियल आएगा. फिर उसको क्या करते हैं, कंप्रेस करते हैं. इसका देखो ये कमती हो रहा है ना, इसका मतलब क्या है, कॉम्प्रेशन हो रहा है मटेरियल का. मटेरियल, द ग्रेन्यूल बिकम अ लिक्विड. इधर यहाँ ही, क्योंकि यहाँ प्रेशर है एंड टेम्परेचर ऊपर से है, राइट. therefore viscosity goes on decreasing, and that's why the material, the granule become a liquid form. आणि इधर का काम क्या है, इधर का काम ये मेटेरियल का काम कितना है कि जितना मोड भरने का है उतना ही मटेरियल छोड़ने का आगे. इसका काम मेल्टिंग जोन का और मीटरिंग जोन का. मीटरिंग का मीनिंग है वही है, मीटर ने सपोज 30 mm, ml, 40 ml, 50 ml, 100 ml, बस उतना ही ये काम करेगा. मीटरिंग जोन ये काम क्या, ग्रेन्यूल को लिक्विड करेगा, वो यहाँ पे छोड़ देगा. ये इसका काम क्या, ग्रेन्यूल लेने का. फीड जोन टेक ग्रेन्यूल, compression zone will try to make the granule into the molten mass or liquid form. Then compression zone will push the liquid melt into the metering zone. And the work of metering zone is to inject the material or to pass the material at the injection stroke as per the size of the mold. यहाँ पे जितना मोड रहेगा उतना ही मेल्ट को अंदर मीटरिंग करेगा. I told you 70 ml, 50 ml, like that. Depends upon the material. Now, see now here, any machine have a 3 major zone. One is the clamping zone, clamping unit, plasticizing unit, injection unit, and the power unit. Yani drive systems. The clamping unit consists of 2 plate as known as a mode pattern that we have seen already, fixed pattern and stationary pattern, and the movable pattern. The mode is constituted in a 2 halves. Each half is mounted on the 2 plate. That also we have seen. See now here, the 1 plate is fixed in a position that also we have seen and known as the headstock mold plate and a last solar plate. The other plate is a movable pattern. These two plates are mounted on a four or two tie bars. That also we have seen. There are four tie bars. The movable pattern, which is known as the moving pattern, and the four stroke, these are tie bars. There are four tie bars. The moving plate is connected to the hydraulic cylinder by a platen on ramp to give the clamping force. That is as well as the moment. In some machine, the locking force is achieved by the mechanical link connected to the hydraulic unit. That is a toggle systems, right? Single toggle, double toggle. This mechanical linkage is known as a toggle. And this mechanism with this type of locking systems are known as a toggle. That we are going to see there. Single toggle, double toggle, their advantages. Other machines are known as a direct locking machines. This whole assembly is mounted on a base, correct? Now, injection unit. That also we have seen here. Plasticizing unit and a injection unit consist of the heating cylinder and plunger. Plunger means screw. This is the old type. Therefore, you can say here screw also to inject the molten mass of the material. In earlier mechanism, the melting of the thermoplastic was achieved by the fixing the cylinder with the resistance electrical heaters that we also, I told you, the band heaters. A plunger or a further used to inject the molten material into the mold. हम लोग प्लंजर का यूज क्या करते हैं? मटेरियल इंजेक्ट करने के लिए यूज करते हैं. Plastic, being a poor conductor of a heat, created problems in so much as it was not possible to get the satisfactory homogeneous melt. To achieve a good melt, the heating is required. Now regarding the power. See now here, friend, the power unit consists of an electrical motor, hydraulic pumps to pump the oil, directional and pressure control valves. See, there are pressure control valve, direction control valve that we are going to see in a hydraulic circuit. The electric motor drives the pump, which pumps the hydraulic fluid in the systems. The directional control valve governs the flow of hydraulic fluid to prepare the various operations. Pressure control valves regulate the pressure in the system. Therefore, see pressure valve, use of pressure valve and directional control valve. We have a circuit that we will going to study afterwards in hydraulics and pneumatics. The whole operation of a closing movement, clamping force, and the injection is done automatically. Therefore, friend, if you see in the modern injection molding machine, we have a very optimum and specific power control there. See, I have a video that you can go through this. And if you have any question, please ask me. I'm here. Okay. So, sound is there. Sound is there, friend. Hello. 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 Hello, am I audible to you?
Sir, no, yeah, you're audible, but no sound. Sound was not there for video.
1 minute, 1 minute.
Still no background audio, sir. Sir, we are unable to listen any video audio, sir. Is audio is there? Can you hear us, sir? Hello? Are you there, sir?
Hello, hello.
Sir, no, no audio, sir, no audio.
No, audio is only sound is there. Nothing. They're not explaining here. Only the
Okay, okay,
sound machine
okay,
sound is there. Therefore, not
okay,
to
okay,
worry.
then it's okay.
Yeah, yeah, yeah. See, friend, this is a very automation acquire in this. There are two type of modes are there, and you are getting a two impression simultaneously from this video, right? And you have seen that there's a toggle systems use. There's no direct hydraulic systems. If you see here, the the clamping unit of this, then you will get idea how this machine work, right? See here, the two cavity machine, right? And the cycle time is 1 point. Cycle time is 1.9 second. See now here, this is a clamping unit, right? This is the injection unit. Okay, this is a control panel on the machine. You can control anything from this. See, this is the animation, right? See how this is the ejector here. See mode, this is a mode. This is a fixed pattern here. This is a movable pattern. And how that is showing, this is, see temperature here, feed zone, compression zone, and metering zone, right? Now afterwards, if you see, this is the all parameter they are showing on the, this is a graph. How much speed is there? How many pressure is there? Everything they are showing here. Now the injection pressure kitna hai, clamping pressure kitna hai, that you will get from this place. And say this is a robo. This is a white wala, a robo काम कर रहा है इधर. Direct robotic. कुछ मैन्युअली नहीं है. देखो, this is a toggle system, friend. This is toggle. There one toggle, second toggle. Therefore, this is called a double toggle clamping system. Double toggle clamping system. See here, there is no a hydraulic system. It's a completely toggle system is there. Therefore, the clamping of this machine is done by the double toggle system. कभी कभी सिंगल होता है इतना ही. अभी अभी बड़ा मशीन है, यार 2 आर्टिकल बन रहा है, तो अपने को क्या है इधर, तो इधर दे हैव शोन अस ए डबल टोगल, राइट? यानी दो, अपने को दो टोगल मिल रहा है, बराबर है, सिस्टम देखने के लिए मिल रहा है. एंड दिस इज अ वेरी यूनिक प्रोसेस, फ्रेंड. सी नाउ हियर, क्लैंपिंग साइड, इंजेक्शन साइड, बीच में इधर मोल्ड, एंड दिस इज a control unit. Okay, now these lines are there. These are just animation I told you just now. This is a fixed pattern, half mode. This is again a half mode, right? A core here, a cavity here, right? So everything you are going to see here, temperature कितना है, everything you are getting on the animation. The screen board होता है, you will get the microprocessor machine, you will get all details there. See, these are the two impression or two article you are getting simultaneously. And this is the automation, right? The robo will take the two article immediately from the opening of the board, and it will just placing there, right? And I told you the double toggle systems. Okay. If you see now here, in this case here, these pipes are nothing but the cooling off mode. See now here, cooling. ये कूलिंग हो रहा है, देखो यहाँ पे ये जो पाइप दिख रहा है ना अपने को, ये फीमेल मोड है और ये मेल मोड है. इसके ऊपर क्या हो रहा है, ये ठंडा हो रहा है मोड. जो टाई बार, इधर एक टाई बार है, इधर एक टाई बार है, वो दिखता नहीं है अपने को, राइट? एंड सी, दीज आर द कूलिंग प्रोवाइडेड. सी कूलिंग प्रोवाइडेड, यहाँ से ठंडा पानी आता है, यहाँ से हॉट वाटर बाहर जाता है. सी नाउ फ्रॉम दिस प्लेस, देयरफॉर complete circulation of water, right? It will happening here. Okay. and the cycle time is only 1.9 seconds. Am I audible to you? Hello? Am I audible to you? See, all the automation is taking place. See the speed of the robo. It's very high. Hello? 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 Am I audible to you?
Yes, sir, you
Hello?
are audible, sir.
Ha. Now see, you have seen the a complete animation of the induction molding machine, right? We have again some, right, some type of videos are there. I will show you the in the next lecture. But now, if you see the inline screw system, yani, this is a that a machine, screw type machine, right? The inline screw systems or a screw ram system is also called as the most important in the induction molding machine. I told you, injection machine having a screw is a very well-known machine in the market. Now, if you see here, one cylinder, screw, screw rotation, which will plasticize the material, right? And lastly, injection. And the mate is converted into the solid in the mold. And then mold opening, right? We are getting the article by this way. The material applied through the hopper is taken by the flight, right? And it is a falling from the hopper to the feed section, right? Due to the friction between the barrel and the material. It's a very important frame. There is a friction also. If you are passing the heat, you are setting the heaters on the feed zone, compression zone, and metering zone. Still, the heat is again developed inside due to the friction between the granule, between the barrel and the granules. Right, that is very important. Now, this friction between the material and the granule is very high, right? But there should not be friction between the screw and the granule. Remember this thing. Frictional heat develop only the granule and the barrel, but the frictional heat not developed by the screw and the material or granules. Therefore, there is a high degree of slippage between the screw and the granule, and there is a low degree of slippage between the granule and the barrel, inside barrel. That you have to keep in mind. Therefore, the frictional heat is developed due to the friction between granule and the inside cylinder part. from the inside. Now, if you see the short size can be therefore usually controlled by the stopping the screw rotation and predetermine the position. When the pre-plasticizing operation is complete, that means complete plasticization take place. The screw is moved forward under the pressure, pushing the elastic material or plastic material into the mold that we have seen in the video also and in the previous slide. Now, see the cycle of the injection molding process. Uh, can we see this tomorrow injection cycle, friend?
Yes, sir.
Hello.
Tomorrow, sir. Yes, sir. Tomorrow, okay, sir.
Yeah, yeah. We will go in detail now, right?
Tomorrow Saturday class. Saturday class is there tomorrow.
Arey, no, not tomorrow. Monday we will
Yes, sir.
take.
Okay, okay,
Yeah,
sir.
yeah. Okay, Monday we will take now in
And sir,
detail. Don't.
what about PPT slide? All this which you covered, you will share at a
Uh,
time or?
No, the department, there, see, this IPI Indian Plastic Institute, they always give all students my this PPT, right? By the from the office only, and that will give at the end of the my session. Now I will take your lecture this month and next month also, right? Even maybe in the February also, right? Therefore, I have now many lectures. Don't worry, I am there with you, and you will
Yes,
get
sir.
all
That's what,
details.
sir. What lecture already covered? If you can get the slides
Uh, yes, yeah,
simultaneously, we can at least
no,
refresh.
they will segregate the everything and they will hand over to email to you all details. Don't worry. They
At the
always do
end,
the
after 2 months, sir.
yeah. No, after 1 month also they will now they will preparing there now in the office, right? See, they are now the officer told me now that sir, you just make a big that screen so that they can collect everything. They are recording everything, friend. Don't worry. Okay, you will get a complete recording of my lecture. Okay.
Sir, no, recording we are getting. My point is that slides, sir.
No, slide with recording. Slide with recording you will get.
Okay,
Okay.
sir.
Yeah. Bye. We will meet now on Monday. Good night.
Monday, what topic will cover?
Same. I will start from this place only. Cycle.
Uh, Only circle, but apart from circle, but any new topic?
No. This topic, injection molding is a very vast topic. Don't worry. Again,
Okay, sir.
there are 5 to 5 lectures. 4 to 5 lectures only on this
Okay, sir.
topic. When it
Okay,
will,
sir.
it will set in your mind completely. Don't worry. Okay. Yeah. Good night.
Good night, sir. Happy weekend, sir.
Yeah. Same to you. Same to you.
आपके पास तुम्हें भी नहीं मिलेगा